Hey guys, welcome to the channel, and in this video I will be explaining a concept based on the queue. So this question is asked in many interview question, and it is a very general problem which is very important for any interview preparation and coding rounds. So now first look at the question using with the help of the example, and after that I will show you how to code this. Let's say suppose we have given this 5 stations, that is gas stations, which is represented with this index values, like this is 0th gas station, first, second, third, fourth, and so on. So we've given this 5 gas stations, and along with that we have given the gas numbers. That means if we have a car, let's say, then the car from any particular gas station, how many liters of gas it can fill into this car is given in this gas array. So in the 0th gas station, if a car is at 0th gas station, then it can take a fuel of 1 liter. If it is in the first gas station, then it can take a fuel of 2 liters, and so on. And remember one thing, every gas station has infinite number of fuels, okay, but it can provide only a fuel of 1 liter, 2 liter, 3 liter, 4 liter, 5 liter accordingly, okay. And the cost area represent that from moving to this gas station 1 to gas station 2, the amount of fuel used is 3 liters. So this is represented with the help of this cost array, okay. Now what our task is, our task is to find that gas stations from which when we start we reach to that gas station again from which we have started. Like if I start with this gas station 1, then after completing this whole round we are again get back to this gas station 1. So we have to find that gas station ID. So we can solve this question with the help of the queue data structure. Without queue also you can solve this question, but it can incur more time complexity. Like what we can do, from each gas station we start our first pointer, that is our I loop, and j loop moves from the second pointer. So this, when we use the method of 2 for loops, it incurs a cost of O of n square. So to reduce the cost of this problem from O of n square to further down, we use the concept of queue data structure. So in the queue data structure, what we're gonna maintain is, we're gonna maintain one queue which will keep track of all the gas station along with the petrols and the petrol we are left with, okay. So now let's say we started our journey from this gas station number 1. At gas station number 1 we have in our car 0 fuel, and the gas provided by this gas station is of 1 liter. So overall gas, our car has 1 liter and it has to travel a distance which incurs a cost of 3 liters of gas. So it is not possible. So first condition you need to check is, if gas at any gas station is less than the cost incurred to go from one station to another. So this condition you need to check. Along with the condition you need to check is if the queue is empty. So these two conditions you need to check. So in the first case we check that the queue is empty and gas of I is less than the cost of I. So in this case what we're gonna do is, so this is not a valid start point as we know, because currently we have 1 liter of gas and we have to travel 3 liters. So this is not the possible starting index. So we are not inserting this value into our queue, and we increment our index to the next location. Now we are at here, and what we need to have is, we have a fuel of 2 liter and the cost which it incurred to go from this station to this station 3 is of 4. So this is also false in this condition. So this is not possible starting index. So we are increment our I with this location. When we add this index 2, we have a fuel of 3 and we have to travel 5. So this is also not a possible start location, so we are at this location 4. Now we are at 4 and we have to travel 1, so this is valid. Okay, so we have 4 liter of gas and we have to travel a distance which incurs a cost of 1 liter of gas. So we are left with 3 more liters of gas. So this can be one of the valid start location, and we insert this pair into our queue. So we insert the pair like we have 4 liter initially and we incur a cost of 1 liter. So this is the valid entry into this queue. So when we travel this, we have 3 liters of gas still remaining, so we can use this 3 liter for the next operation, for the next destination. Now from the previous station we are left with 3 liters of fuel, and in this station 5 we have 5 more liters of gas. So currently we have 8 liters of gas and it incurs a cost of 2 liter. So as I shown here also, so it incurs a gas of 2 liter also. So we are now left with 6 liters of gas. So this is also one valid distance which we can travel. So we are again inserted this values into the queue. Now for the next situation, this 6 liter of gas can also be used, and at this location 1, what we have 1 liters of gas which can be added, and we have to travel a distance which incurs a cost of 3 liters of gas. So we have to subtract that 3 and we are again left with 4 liters of gas. So this is also valid entry and we can take this distance also. So this entry is also inserted into the queue. So remember one thing, when we start at this location, this was not a valid entry into the queue because initially we have to travel 3 distance which incurs a cost of 3 liters, but we have 1 liter, so we are not starting with that location. But when we started this location index 3, so we came to this point and this is also satisfied. Now we are left with 4 liters of gas. So this can be added for the next distance, and now we are at this index 1. Here we fuel our car with 2 liters of gas, so we are now left with 6 liters of gas, and we have to travel a distance which incurs a cost of 4 liter. So we subtract that 4 liter and now also we are still left with 2 liters of gas. So this is also valid entry, so we inserted this also into our queue. After that, this 2 liter added to the next distance which we need to travel, and in this we are at this location index 2, and here we fuel our car with 3 liters of gas. So we are currently at 5 liter and we have to travel a distance of 5 liter. So we are now left with 0 liters of gas, but it's okay, we traveled that distance also, so that value is also entered into this queue. So when the queue reaches the size of the number of gas station, so here the gas stations are 5 and our queue size is also 5. So in this case we found out that when we start at this location where the fuel consumption is 4 liter, then it can travel all the gas station and again came back to the 4th index or the 3rd index. Okay, now we have to return this index, not this gas and cost, we have to return this index. So for that, what we gonna do is we just simply iterate in this our arrays and check out that whatever is the first value, it matches with any of this valid pairs or not. So it matches with this 4 one. So we find it out that this was the index from when we started, we again came back to the same index again by traveling all the distances. So remember one thing, in the worst case we have to travel O of 2n, because when we start at this location 4, so we have to again came back to 4, so it incurs one more cycle. So in worst case, if we start with this 5, so it again came back to 5, so it incurs one cycle. So overall we have to move twice in this array in worst case. So overall time complexity is order of 2n and overall space complexity is O of n, because we are taking an extra queue of size equal to n. Let's again solve this one more example and try to make this little more clear. Here we have 3 gas stations, 0, 1, 2 indexed, and we have a fuel of 2 here, we have a fuel of 3 here, and fuel of 4 here, and it has to travel a distance which incurs a cost of fuel 3 liters, 4 liters, and 3 liters. So now when we use the previous concept which we have discussed is, we have to maintain one queue and we have to start with this our start location, and in worst case we can go 2 rounds of this array. So when we are starting at this location, the first condition we need to check is that if gas is less than the cost, then it is not a valid start point. This is also not a valid start point, and this can be one of the valid start points. So here what we have to insert this into our queue. We have initially a fuel of 0, and for this gas station incurs a fuel of 4 liter, and we have used 3 liters of it, so we have remaining with 1 liter of fuel. So this can be fuel to transfer to the next iteration. So next iteration we are starting at this location, and here what we have 2 liters of fuel with which we use 3 liters, so we are left with 0 liters of fuel. So it's fine, so we can insert this values also into the queue. After that we are left with 0 liters of fuel, so this can be shifted to the next iteration, and here we have 3 liters of fuel provided, and we can use 4 liter for the traveling of this distance. So we are left with minus 1 liter of fuel. That means that distance is not covered properly. So in this case what we are going to do is, we are not inserting this entry into the queue. Instead of that we are starting popping out entry from the beginning of the queue. So when we start popping out entries from the beginning of the queue, what we need to check is, we pop this value 43 from the queue. So this was the cost which we have traveled, and this fuel is consumed, and this is the gas which we have filled with this gas station. So we are left with this entry minus 1. We have to add that distance which we have traveled, and it consumed 3 liters of fuel, and we have to subtract the fuel which we are provided at the gas station, that is 4 liter. So we are again left with minus 2, which is less than 0. So in this case this value is popped only. So in this case pop the second value from the queue. So this is also popped, and the result is added and subtracted. Like 3 liters of fuel we used in traveling, so add them back to, and we use the 2 liter fuel, or we have provided with 2 liter fuels from the gas station, so we have to subtract that. So that is also equal to minus 1. So this is also less than 0. So now queue is empty. So when queue is empty, we need to jump to the next index I. So here we are again back to this location, and this is value is also inserted. But now, as I said, that in worst case we can go 2 rounds of this array, and after that the same value repeats, the same process repeats. So when this is completed twice, then we need to check the size of our array. If it is not equal to the size of the gas stations, so in this case it's 1, so 1 is not equal to 3, so in this case we have to return minus 1. So minus 1 indicate that there is no gas station from where when we start we will cover all the journey and go back to this starting location again. So hope you get this idea with the help of this example now. So now let's look at the code for it. So as you can see with the help of this code, that we have our gas stations. That means this value indicate that how many fuel we can take, and this cost indicate that how many fuel it used to travel from one station to other station. Okay, and after that I have passed this to the function that is can complete circuit, because we have to complete this circuit. So the code is bit lengthy, but it's easy to understand. So now let's dive into this. Okay, we have this gas, along with that we have the cost, and we have created a queue, and I have created this array because we can at most take 2 circular rounds. So for 2 circular round I have put this values of gas and cost as a pair in this array twice only. Okay, so what I mean by twice only means, so this values to I have copied into the array twice, like this was the first time, and second again 3 4 2 3 4 and 3 4 3. So the array will contain this values twice, because at first case we can go 2 rounds of this array. So that's the simple initialization only, no need to worry about it. And I have created one variable which is previous, which keeps hold of the fuel which is left when we came from the last or previous gas station. Now what we have this for loop which is iterating on our array size. Array size, I have shown that if we have 5 gas stations, then we have created an array of 10 in which the same value repeats, so that we can go worst case of 2 rounds. The first condition we need to check is if queue is empty. So whenever the queue is empty, previous is 0 only because we are not left with any fuel from the previous gas station, and we have to check that if the fuel present at any gas station is less than the fuel it incurs to travel from one gas station to another. If this is the condition, simply continue, because we can't insert that into our queue. Else insert that pair of the fuel along with the distance onto the queue, and previous value is updated with first minus second, because first is the fuel which is currently at the gas station, and second is the fuel which it costs to move from one gas station to another. So previous value is updated with that only. So we are left with how much fuel it is stored in this previous variable. Now after that, what we have this else. That means if queue is not empty, then we have to check if the queue size is equal to the gas station size, then it means that we have covered all the gas stations. So in this case, simply break this for loop. If this is not the case, then what we need to do, we need to first see what is the current gas we are at. So whatever is the previous plus the current fuel is at the current gas station. So this is the gas current, currently how many gas we have left. Tool distance is the distance which we need to travel and how much fuel it can be used, and difference is the thing which we got from the difference of this. That means we are now left with how much fuel. Okay, so this condition shows that while not q.empty and difference is less than 0. So this is the case which I explained you in the second example, where we are popping elements from front of the queue and add it to our difference variable. That is the negative value which we have got. Okay, so this is that condition only for popping the elements from the front of the queue. So until this difference becomes positive, we have to pop this values from to the queue. So once this is checked, then we have to check that if queue is empty or not. So if queue is empty, then this is the same condition which we have applied for the queue is empty in the above code. And if queue is not empty, then we have to push that pair onto the queue and make previous as gas current minus tool distance, because now this previous will contribute fuel to the next iteration. Okay, and once all this is done, what we need to check is, we need to check if the queue size is less than gas size, then return -1, as I showed you in the example 2. And if this is not the case, then whatever is the front, we have to find the index for that gas station. So simply check that, and whatever is the index, then return that. Okay, so return answer will hold the particular index which we are currently at. Okay, so what we are doing here is, if we are iterating on this gas size, and we are checking that if it is equal to first and cost of I is equal to second, then answer is updated with that high index and return the return answer. So now let's look at the working of this. So when we compile it, So what it is mistake? Okay, it's return answer, not answer, it return answer. And when we compile it again, it compiled successfully, and when we run it, it returns the index of 3 as I showed you in the first example for this gas and cost. So hope you got this question. If you find any difficulty, feel free to ask in the comment section and I will answer for that for you. Okay, thank you.